Hello everyone, in this video we'll be looking at the giant covalent structure of graphite. And you can see over screen here, graphite is used for a lot of things. It's the wonder material of the 21st century. You see some graphite stones here, graphite in the pencil, graphite armor, right? And let's see why graphite is such an interesting material. So in this video, we'll be able to link the structures and the physical properties together in graphite. Understand this new word here, allotrope. State the structure, the particle, and the bonding within graphite. Understand what does this new word also mean, delocalized. Explain why graphite is a high melting point, and very interesting, why graphite can conduct electricity, and why is graphite slippery and smooth. So these are the three physical properties that we have found out about graphite. Firstly, it's an extremely high melting point, right? Yet you can conduct electricity in any state, and it's actually very slippery and very smooth. So the extremely high melting point, we should know, is actually attributed to very strong attractive forces. So what are these strong attractive forces within graphite? Graphite can also conduct electricity in any state, means that there must be some sort of charged particles present, and we will find out what are these charged particles. But yet, although it's a high melting and boiling point, right? Unlike diamond, which is hard, graphite is actually soft, slippery, and smooth. So that means while there are strong attractive forces, there are also actually weak forces available, right, in the graphite, such that it's also slippery and smooth. So firstly, we talk about the word allotrope. So graphite, right, is actually also just carbon. Every atom in graphite is a carbon atom. And you might have noticed that that's the same thing as diamond. So diamond and graphite are what we call allotropes of carbon, right? Allotropes are actually different physical forms of the very same element. So charcoal, diamond, graphite, graphene, fullerene, they are actually all carbon, right? However, they all exist in different forms, but they are exactly the same element. So therefore, we call them allotropes of carbon, right? So what are the particles present? Same thing, carbon atoms. And very interestingly, graphite has two different types of bonding. Firstly, one carbon atom in graphite is bonded to 3 other carbon atoms, which is different from diamond. Diamond is 1 is bonded to 4, but graphite is 1 is bonded to 3. Okay, and graphite actually has a layered structure, so it's like pieces of paper being stacked on each other. It's a layered structure, right? And therefore, there are actually weak intermolecular forces between the layers. So how do we describe the structure of graphite? So graphite is actually layers of carbon atoms covalently bonded to 3 other carbon atoms in a hexagonal arrangement. So notice how this is actually different from diamond, right? And these layers are actually held together, right? These like layers of paper are actually held together by weaker intermolecular forces of attraction. So there we go. We have the two forces, the strong covalent bonds holding the diamond in the layer, and then between the layers, there are actually these weak intermolecular forces of attraction. So how does it look like? So a hexagon is a 6-sided figure. So we have one carbon atom, and this carbon atom is bound to 3 other carbon atoms. And every carbon atom is bonded to a further 3 other carbon atoms, and it forms this hexagonal arrangement. So you can imagine this is like a mesh, and this mesh is actually flat, right? And if you look at this diagram here, this flat arrangement, and this is one layer, and if we actually look at the other direction of graphite, we can see that these are multiple layers, and these multiple layers, right, have actually weak intermolecular forces between these layers. So it's very difficult to destroy the layers, but it's very easy to move the layers around. Okay, so the next thing we must notice for graphite is that carbon has 4 valence electrons. However, each carbon atom only bonds with 3 other carbon atoms. So you can see that there's this red electron that I highlighted here. This electron is not used in bonding. So this valence electron is not used in bonding, and it is actually able to sort of escape the carbon atom. So where does it escape to? So you see these electrons, the red dots and the purple dots, right? It actually escapes to the spaces between the layers. And these electrons are actually able to travel up and down within these layers. So there are actually moving electrons within the graphite. graphite structure. They can move this direction, however, they cannot travel through the layers. They can only travel along the layers. So what does this mean is that we did this experiment where the electricity conducts graphite in this direction, as you can see, but if we put the conductivity probes on the top and at the bottom, there's actually no conducting of electricity. It only conducts the electricity in this direction. Right, so let's learn how to explain the various properties. So firstly, a high melting and boiling point. So when we are actually melting or boiling graphite, we are not separating the layers, we are actually breaking the covalent bonds. So how we explain the high melting and boiling point is that since there are strong covalent bonds between every carbon atom with 3 other carbon atoms in hexagonal arrangement, and as a lot of energy is required to break these bonds. Remember, break bonds, overcome forces. This time here is bonds, so break the bonds. Therefore, graphite has a high melting point. Right, now, this explanation is extremely important. We always like to talk about this one, why graphite can conduct electricity in any state. So for graphite to conduct electricity in any state, right, that means there must be delocalized mobile electrons, right? So this delocalized, as what I explained, has escaped the atom and can fly along the layers. So why is there delocalized mobile electrons? Because each carbon in graphite is actually only bonded to 3 other carbon atoms. And as this means that each carbon atom has 1 valence electron not used to form bonds, and as these are mobile delocalized electrons, therefore graphite can conduct electricity in any state. Lastly, explain why graphite is actually used as a lubricant. In order for something to use as a lubricant, it has to be slippery and smooth. So there must be some sort of weak attractive force. So how do you explain this? Therefore, graphite is slippery and smooth and can be used as a lubricant. And because little energy is required to overcome the interaction and each layer can slide over one another. So what are these attraction? What are these forces of attraction? Is that since each layer of graphite is held together by a weak intermolecular force of attraction, and as little energy is actually required to overcome this attraction, and each layer can slide over one another. Therefore, graphite is slippery and smooth and can be used as a lubricant. Right, so that's all for graphite. Graphite is a very interesting material, so please study and understand the structure of it very well. Right, so thank you, all the best. Bye bye.